Okay. Does the microphone actually come through? Okay, great. Thanks. So thank you, Thor, for giving us a recount of your experience on the game day, and congratulations on being a part of the winning team. That is the exciting part, and I'm literally I can't find my slides, so yeah, we're doing it this way, and I just accept that. Yeah. Yes, enter new bug is definitely on there. What's that? Oh. Thank you.
There we go.
All right.
There's the full screen button right there. At the bottom center.
Sorry, I got my.
There it is. Full screen. To the right. To the right.
Yay. Yeah, right. I broke my glasses yesterday. So, okay. So we start off the game this is a game scenario, right? So the whole concept of the game itself is to ensure that we have a concept, and a part of the process, and an idea for people to latch onto. So there's role play, and the concept of the role play is to get up and to just basically be the CFO of a startup, right? So you just walk up and you're like, you guys are all I don't know if you know it, but you were all fired from your jobs yesterday, and that's why you're here now, And then we give a little bit of information that's associated with the experience, like, hey, we were running this company really great, but then a couple things happened, some people quit, like all of them, and then we've started to get some customer feedback, and the concepts there are to get into the specific quests. Now, a quest has an objective, right? So in this case, what we wanted to do is create a social aspect. You want to make sure that you can generate some sort of common application that can be shopped around to other teams. So if you want a good experience, right, you want to build in that connection, right? So what we do is we build a game. That game is then served out from in this case, an instance. We were using Red Hat Enterprise Linux on the Cloudy Hops. And then you're capable of playing the game, but then you're also capable of getting other people to play the game. And when other teams play the game, you get points. So you want to shop around and make sure that happens. And effectively, that gives each one of the team members an opportunity to participate, regardless of the level, right? So the reason you want the social aspect is because you're going to have people who have zero level experience with the products that you're trying to showcase, and you're going to have people who are expert level. And you want to make sure that you've covered the gambit of things that can be associated. So that somebody has to choose a more social role, they still can. And that kind of goes along, I mean, in my opinion, that goes along with the sentiments of the way that we handle most things in the open source community. So you want to make sure everyone stays included. This one, the Cloudy Hops, this has a modified Flappy Bird in it, by the way, that has a Red Hat hat as the Flappy Bird.
Right at the beginning, the Red Hat.
Right. Yeah, that's right. That's right. Yeah, it doesn't work. Yeah, that's right. Hence this customer experience, right? So good thing you were there.
Polite and grammatically correct to be real people.
And then this one, the Goldfish, we actually there was a Rick and Morty concentration game, and we took the Rick and Morty concentration game and then rebranded it as a Red Hat concentration game. So we used a lot of Red Hat icons to build out the structure for it. the way that those the way that translates is you expose it on the OpenShift, or in this case on a rail box, but the concept is to expose that interface for access and then to make that social experience happen. This game is built on Ansible and Ansible playbooks, and centers around the experience of having a merge conflict that you've got to figure out how to resolve in the configuration. There's a team dashboard. The dashboard has all the information, provides the experience, and this is what it looks like. You end up with a hash on that screen that basically takes you to your own console. So once you put the hash in, you get a table number, which is so everybody can use that. Thor said he thought they should use one laptop instead of having two laptops. The one laptop would have the team dashboard on it, but with two laptops, you can have the same team dashboard on two laptops. If you have 4 players, those 4 players can do that. And the way that the event engine that we use is established, you can do that with teams that are in different countries, effectively, right? So the concept of the game day is not something that is localized. It's something that we can, in fact, bring to all of the members of a team, even if they're not geographically located in the same place. When you log in, you end up with access to the quest itself. And since I'm having trouble with my slides, the quest is effectively the part that is the interaction for the players. So we have a event engine that effectively covers the whole thing, right? And then we have multiple accounts for each one of the teams. Each team gets their own account. So for one table, so if you have one table with 4 seats, and everyone is playing on this table, that's one player account, right? So if you look at that, you would think about it as one AWS account. Now, the event engine has a master account. So this main account here includes all of the requirements for the game. So you would see one cloud. We do this with DevOps, of course. So you get one CloudFormation template that deploys the entire infrastructure for the main account, and that main account becomes the command and control for the entire game. And then, as a developer, as someone who is developing for the game day, you're building out a CloudFormation template that has all of the content in it. Now, for our internal games, right, this may it would probably be more. This would be all that you would do. But for Red Hat, we determined that there are some things that we can't deploy into the configuration here based on policy requirements. And so instead of just using the team accounts here, we're working with the demo team. And the demo team at Red Hat has provided us the ability to stand up additional customer resources so that as we interface here, right, so this basically is an event loop, right, with a dashboard in it. So the dashboard for the game exposes the content from the team account to the main account. The main account then can do monitoring. It can do command and control in the association, and then you get back a score. So with all of this, with the way this works, we'll have resources here that are monitoring and managing the game. This is where your event engine is. So as the players make changes to each one of the individual quests, and the quests are actually here, deployed in the master, in this main account where the players don't have access. The players have access to all the resources that are down here. This is where you're deploying instances, and you have different kinds of applications running, on top of having the ability to have an OpenShift configuration on this side that's deployed through Agnostic D. And if you haven't seen Agnostic D, this is the tool that the demo team is using to create all of the configurations that they provide through the demo portal. So any of you who are looking to learn about services, right, on Red Hat would probably go to the demo portal. So you'll understand the infrastructure that we're using for the game because it is immediately available. So as someone who wants to build a quest, if you want to build your own Goldie Fish, right, you would create a template using the development kit. Now, the development kit provides you an entire configuration that lives instead of in two accounts, right? Instead of being set up in main and team, it combines the two, so that as you're making modifications to the configuration, like let's say you wanted to build out an OpenShift configuration on the demo portal, you build that out, it's successful, you deploy the infrastructure to support connecting to it, right? Like instances that you can use through terminal or through a graphic display. You would then be able to take that entire configuration and deploy it in a single account while you're doing your development process. So what we do is we carry the development process in a single Git repository, and then that way we can split out what goes into the main account for control, and we can split out what goes into the team account into two different templates. Any questions so far? So one of the other things that we wanted to cover is scoring. In the gameplay, we want to make sure that people are engaged and that the experience is something that makes them, that they feel their progress. So you want to have various stages of scoring. Each one of the opportunities for building score can be greater or lesser. It all depends. Usually they're attached to actions. So if we go back to looking at the quest itself, these quests will have individual components. Like, for example, the first thing you do in the Cloudy Hops game is to identify the endpoint that the game will be served from, right? So that's identifying what the URI is for that specific server. When you identify what the URI is successfully, you get points, right? When that URI is identified and the Cloudy Hops no worky, then you get no points. So you have to determine exactly what component parts are functional, what are not, and then add hints. So now that I know that my score is greater or lesser based on success, right? Then I can say if I want a score for an endpoint, so you gave me an endpoint, I give you 1,000 points. You ask for a hint because you don't know what the endpoint is. I give you -6, right? Something like that. And that's not that, this represents like a very small like a basic hint, right? And incrementally, you know that everybody's going to get 1,000 points for the endpoint, but not everybody is going to really realize exactly what needs to happen to get that endpoint in place. So they're going to take one of those little hints, and then maybe they need a bigger hint and a bigger hint, and just that subtraction of like the smaller amount of points, you end up with very interesting variations on the scoring. And we saw that yesterday. It was the first thing. Was it you, Thor, who was like, "How did we get?" No, it was Marcel who said, "How do we get negative points?" But it didn't matter. It got a couple million after that. So, and this represents like a first. So, these are first attempts. Game complexity is in the next step in our process, right? Is understanding that if you've achieved one thing, that can't be the end of the game, right? We want this to go on. We want people to feel the experience and the warmth of actual production, right? We don't want them to be able to rest. So, as you build out these quests, we don't. No rest for you. That's right. Well, I mean, if you're going to win the game, come on. Like if you're going to maintain their attention and the commitment, there has to be some next level. And so what we do is we build out multiple layers for each one of the individual games. For Cloudy Hops and Goldiefish, we don't have as many levels as we would like to have. We're working on that, right? So love to have your help in doing that. And then so the complexity means you have to layer in more of the company vision, right? So a lot of what we do there is so to add networking complexity, we have a security team we call Threat Slayer, and we use Threat Slayer for a lot of things. Like Threat Slayer comes in and actually has to apply policy. And if you've ever worked in a cloud environment, there's identity access controls, there are firewalls, there are access control lists that are so independent of the expectations of a basic instance that the hunt can be quite complex in itself. So we add complexity with our metal band turned security team, and we use other opportunities, natural disasters, complicated action. So what we would like to have in that process is some next level of complexity so that those who are actually achieving at the lower levels can move upwards in that game. We can do a game day for up to 72 hours. So the more complex, the higher number of quests that we have, the easier it is for us to sustain attention and entertainment value in those 72 hours. It's really helpful to have a goal in mind that is directly associated with a specific service. Cloudy Hops obviously is structured around two things, which is just basic service enablement, right, and SE Linux controls, And then their container-based system has, the Goldfish configuration has a goal of building a container-based system that is managed on your on a rail system, a rail server, with the added complexity of ensuring that you have an Ansible playbook that is fully functional for the process. And building out and running the Ansible is kind of the strongest methodology that we want to pass through on best practices. But that doesn't mean that the winner is going to use that Ansible playbook. And that is kind of one of the other things that I wanted to talk about, is there's a seemingly random pathway to success. And part of building out this game is discovering how people shortcut your practices, and then how to score that, right? So for us, the idea is to help people along in the context of the best practices. So, and we know those, they're observable, but that doesn't mean everyone is going to be able, is going to know exactly where to look. We were laughing about this yesterday, is that almost everything that we had, if you had gone to the rail documentation, you actually would have found the steps to fix the problem, but nobody went to the documentation. So as a result, we saw a lot of different things, and there was we had an interesting debate, just by having someone solve a problem in a way that was non-standard. One of the teams literally stood up secondary architecture and wanted to, rebuilt everything on CentOS Stream 7, and then did a deployment. And so the deployment was effective. It worked, but it didn't score them any points. And the interesting part of that was that this was, because this happens in a cloud environment, one of the principles of building out cloud infrastructure is to remain lean, right? So they actually extended the architecture, they doubled the infrastructure requirement by standing up a secondary instance. So there was a question about whether or not this was, they had achieved the goal, and we sort of stepped back, looked at it from both sides, tried to determine what we thought was right, and then just generally agreed that this was an infrastructure mistake. So, and that brings me to the score. Like, the scoring events themselves are deterministic in the basic way, but then there is some room for us to identify and apply some changes to those to the point structure, just to make sure that if someone is working and they're discouraged or they don't understand, that doesn't stop them from getting some sort of an advance, that we, to feel like they're still part of the game. And this is also a part of the structure and practice around this, is that you have to build some compassion into the experience, otherwise you may lose your audience. And lastly, before we just start generally talking about it, or maybe I can show you some code, is the prize structure. So obviously this is Unicorn Rentals, and Unicorn Rentals needs to have something that is mildly representative of the unicorn experience, right? So we try to put things together that are glittery and fun and not practical, because one of the things that is interesting about the game is the thing that is interesting about the game is the play. And it shouldn't be a competition. It should be something where everyone is excited to participate, and everyone is happy when when they finish and they can they don't feel so heavily invested that there's a sense of fairness or complexity in their vision of the game. So we don't want you to feel like you're missing out, right? Which is why we gave a baby unicorn and not a full-size unicorn to the winners this time.
You're keeping the full-size unicorns in the back. You have those, but you're just not giving them out.
We rent them. A lot of times,
You probably don't actually want the unicorn. There's a lot of maintenance work.
Yeah, that's right. Yeah, and that's a point that really made this business what it is today. So the prizes themselves need to be simple, and they need to be they don't need to be heavy investments. And my favorite prize to give out is having your name permanently taped to a plastic unicorn statue. Okay, so with that said, configuration management is really the next step in this, and how we get to the configuration management is through what we call the Quest Development Kit. The Quest Development Kit has all the things that go in the main account, right? And that's a bunch of Lambda functions and some serverless configuration stuff that sets up all of the event-driven actions that come down here. So for Fargate, there's a bunch of containerized applications that we use to do this, and we build them out in a serverless infrastructure so that it's fairly efficient. This part is kind of hard-coded. There's not a whole lot that you can change about how the events are structured, but what events are trigger points and how those are evaluated is part of the Quest experience that you would put in this command account. The command account interacts and executes within the context of the player account. So the player account is leveraged for anything that the user is, like the player is capable of doing. So if you wanted to have, Adam and I have talked about this before. If you wanted to have a full open build system in the cloud, right? We would set up the open build in the team account, and then we would identify actions, notifications that would then trigger point scoring or identification of the unlocking of specific tasks in the quest until we get to such a point that we feel like that section of the task has been completed. Once that's completed, other things can happen. So a second layer can be activated at a later time, right? So as you build one, and then you'll build a single action, and then you can build a secondary action and a tertiary action, and n number of actions right after that that can be enabled in succession on that same quest. Yeah, the sky's the limit. Application space is built in Python, but there is a TypeScript version. So almost all of the work that you're going to do will either be in Python, CloudFormation scripts, Ansible, or TypeScript. Although secondary actions, like if you have something that's functional inside of an application, you can do it from there. Roadmap. So we really enjoyed building out 2 Rails server configurations for the game day, but we are focused on ensuring that we cover the gambit of RHEL products, so that we can make those available to the general, just generally. And we want to start with a modernization component. We have a slot for a quest at AWS reInvent this year, and we're really looking forward to that. And we want that slot to be filled with an OpenShift configuration. So we are working diligently on building out support for the Quarkus Coffee Shop as a component part of the Unicorn games industry. We are working on the Unicorn Cafe. So the Unicorn Cafe will be our next quest, and that will include some modernization steps to get an application onto OpenShift using various components of the OpenShift infrastructure, and we'll be using that to secondarily extend that into space, which is our edge component. So once we have a successful Unicorn Cafe, we'll launch the Unicorn Cafe into space. And we'd love...
Can I ask a question before I go, though?
Sure.
Have you considered, like, Mario Kart mechanics? It would be really fun if you could do a blue shell and, like, go spanner in the works of the team that's ahead.
Oh, like actually link up the teams into an online game.
Well, so in the early days of the game, that happened a lot. And it is quite possible. It is quite possible for us to take that kind of action. So if you're one of the things that we're doing here is we're creating the social experience, and you can bring that on, and then in fact, if you've got let's say from your main account, from your command center can make determinations based on anything. So like if one team had if every other team was using one team as a central source for their game or for whatever it is, for whatever action, like we've built reversers. So literally we have like applications that are just reversers, right? Like you just it just throws a word in, reverses the word, and then provides a hash, and so you get the response is the hash and the reverse of the word. And the hash gets you points. So if everybody was using the same reverser, right? So if the endpoint came from the same team, then you could do something like hit the next level of the game, right? Like destroy all of their networking, right? And so that is definitely a part of the process. You can make those modifications. So. The kit will allow you to do that, and we can do that in the same, consistently in a single account. In terms of the technology that you can use, because we're connected to the demo team, we can use anything that's in the product suite associated with RHEL and OpenShift, and then and actually we can extend that all the way up through the IBM suite. So, plus everything that's associated with AWS, of course, right? Like any secondary service or connected service, we could do that as well. Yeah. Any other questions? Yeah, thanks. Thanks for being here. Yeah, I understand. Yeah.
So, how do you manage to transfer all of these events and messages? Like, have you been using some kind of messaging system, or?
Yeah, well, of course. So inside of Amazon, inside of AWS, the AWS infrastructure, there is a simple notification service. So we use a simple notification service to cross from one account to another, and then we use a queuing system to identify so that if there are messages that we need to carry into another application, we use what we call the simple queue service, and the simple queue service is there for that. A lot of it is also fired off of some simple serverless applications. So there's Lambda functions, and there are container-based workloads that for larger scale decisions, or chains of Lambda functions that in fact will process some of those events in a way that's consistent with the scoreboard and the game, and update the databases that are associated. So there's like a bunch of DynamoDB. There's not only SQL configuration here. There's for the dashboard and for the users and for the hashes that are associated with the accounts. That is the way that you get support for that continuous feedback. We also have, on this side, we have access to streaming services. So we can use Kafka over here. We can use standard message queue on the demo side. So all of the work that we're doing that is connected to the Red Hat portal is communications from here, and then we have an application endpoint. That application endpoint is something it's not shared, right? So this is strictly set for each team. So each team has their own environment, and that environment then is configured for providing information to them, and then also feedback into the main account. So as you make changes here, we have an API that the OpenShift configuration can call and make make updates or changes here. All the basic CRUDL. Anything else? Well, I'm excited for anyone to do the work. If you're interested, please drop us an email, and we will get back to you and make sure that you have everything you need in place to work with us on the quests. Thanks for being here. Yeah. Go ahead.
All the issues are configured in the platform, right? Already.
Yes. Yes, we are breaking everything in a way that is consistent with how this works. And a little bit of history there is that Game Day is based on the application, the way that we build applications, like new services or new region launches. We establish a stress test for Amazon. This is like a basic practice for Amazon. Is you set up or it's a basic practice for anybody who's deploying a service for themselves. But we stress test pretty significantly. Test scale, test the application sustainability and resilience, and then make determinations on what we need to change. Right. So whatever failed, you look at what failed, or you stress it. You look at what failed, and then everything, and then go back to the drawing board and figure out what you need to change in your design. Same thing here. You stand it up. You get other people to use it. Then we will either simulate that there has been a failure based on that stress test, or we can, in fact, we may have a stress that like literally kills it. Right? You might have an auto scaling group that's too small or something like that, and then ultimately you would have to change it if you have enough people hitting your service, right? So as a social experiment, it can also be the thing that causes you to run into your own limitations and then have to make an evaluation on what you're going to do next. That is the project plan. Now, the reason I wanted everybody to come to this talk was because I want them to imagine those possibilities, to understand that from the perspective of being someone who develops a game and then takes that back and takes our development kit and provides us something that can fit into the game experience, or inside of the community-based products that are associated with with the Red Hat ecosystem, all the way up through the more advanced products. We chose to highlight Quarkus because we think that that's a very good fit for the OpenShift experience and targets some people that we think are a little bit more have a little bit less experience around modernization, but really want to have more experience around modernization. So we think that they're going to be very excited about the next iteration of our games.
Yeah, very good experience today.
I'm glad you had a great time. Any other questions? I think we can leave it at that then. Thanks.
I have to unmute myself first, right? Yeah, okay. So I'd say let's start. Thanks everyone for coming, given the beautiful weather outside, and then it's Sunday and the beautiful weather. Welcome to my presentation with the spicy name, All the Things That Didn't Teach You at University. I hope you didn't come here expecting I'll teach you everything you didn't learn at university in 30 minutes. Otherwise you're in for a letdown. So anyway, first the boring part, who am I? I'm Dan Czermak. I'm a software developer working at SUSE. I also do things in the Fedora community, and for my interests are, besides doing things on the computer, also working on development tools. I'm quite passionate about testing, and occasionally when I get to it I write documentation and then break my home automation because I like standing in the dark or implement funky stuff there. If you'd like to stalk me on social media, you can find a few links there. I might post some stuff there, for example, link to the slides, but there will be some later. So now that we are done with the boring part, I'd like to maybe share a bit of a history, because first I thought, yeah, well, so first a disclaimer, I didn't study computer science, so I studied physics. That means a lot of the stuff that I learned for my day job I had to teach myself. And I thought, well, I'd like to share a few things that I learned over the years. I mean, my Unix beard is not that long, so I most certainly don't know everything by far. But I've learned a few things. I wanted to share them, and so I started to write my thoughts down and what I learned over the years, and I realized this thing's gonna start grow and grow and grow and grow, and it's not gonna be a presentation. It's gonna be like 2 lectures, maybe 3, maybe a whole lecture series. So yeah, let's not do that, because I'm gonna tell you things like, yeah, you should test your stuff. You should have a proper staging setup. But no matter how good your staging setup is, you still occasionally will have to go into your production server and just comment out the faulty line and pray that you can get into your production server, unless it's some kind of certified super secure hardware, and you aren't allowed to touch it unless your manager is standing behind you and their manager, and someone is signing that off with their blood. Also, ugly things like most real infrastructure is held together by duct tape, glue, hopes and dreams, and a lot of magic. But also more positive things, like if you want to do today something with computers and with code, you'll have to use version control, and that means Git. I mean, nothing else is really used in practice. If you want to do backend development nowadays, you're going to use Python, Node.js, Golang. In the front end, it's still all JavaScript. WebAssembly is becoming a thing, but it's really not that yet. And if you go into the enterprise world, it's going to be Kotlin, Java, more Java. If you're unlucky, it's also going to be XML, and maybe a bit more Java. And you're going to touch SAP, whether you like it. But, well, some of this stuff will change. Some of this won't. So I would hope that the infra stuff will change, but I'm afraid it won't, because it's been like that for 30 years. But if you work in open source, one thing will really never, ever change, probably, and that's you have to work with people. And the interesting and challenging thing with open source, and when it comes to people, so if you work in a company, you also have to work with people. But you have the same HR department. You're kind of there because you get paid to do your job. And if someone doesn't want to cooperate with you, you can escalate things. Or sometimes it helps, sometimes it doesn't. But there's structures for everything. But if you work in open source, you're there for your own motivation. And the other people, they have their very own motivations. And they can be completely different to yours. Maybe you do it for fun. They do it to put it on their resume. Maybe you're doing it because the software doesn't do a thing, and the other contributors do it for completely different reasons. Maybe they just like the community. Your employers are probably some completely different companies. Maybe a bunch of the contributors do it in their free time, and their HR department won't be bothered if you try to file a complaint, because they do it in their free time. I don't care, not our problem. Maybe they are on a different continent, and even if they do, you do it in your day job, doesn't concern them. People work from all over the world, and you have completely different cultures, which can be a great challenge when it comes to communication. And also one thing that you really shouldn't underestimate is time zones. I mean, most of us probably are sitting in Zoom, Teams, Jitsi, whatever calls all day, and you know the trouble of time zones. But this can be a huge problem for open source projects. If suddenly all the contributors are sitting in North America, and you are in Europe or in Asia, and they decide stuff in a meeting, and for you it's 3 a.m. or it's 12 and you are at your job and you just can't join a call for your free time project in the middle of your working day. And you have people in volunteering positions, maybe that get paid. Maybe you have outside contributors who get paid. You do this in your free time and they tell you, hey, fix this bug for me. No, I'm not going to give you money, sorry. Maybe you have students. And this all makes open source much more challenging than really closed source development, where you just have corporate structures which may or may not provide you with some backing, maybe not. But so that's really I'd say the most challenging part of open source. I mean, you can also just make your project open and not accept any contributions at all. Technically, that's most certainly open source. That's open source to the letter, but in my opinion, it misses out the one big thing, and that's the community. So your open source project usually has some kind of community behind it. And for many projects, a community is really, it's just a bunch of people that work together on a common goal that they share. Usually it's just keeping this project around. And for many open source projects, you just become part of it by showing up, because there's no clear onboarding process. I know there's projects nowadays that have welcome channels, and you can get and they try to onboard you in very friendly ways, which is definitely a good thing. But I know the first open source projects that I joined, I just came there, started fixing bugs, and eventually they told me far quicker than I was comfortable with, hey, yeah, why don't you get merge rights? You sure about that? But yeah, so the point of the community is to have a common goal and really to empower others to work on this shared goal. And since we're dealing here with people, the big question is always, how do you communicate with people? So you got your multiple options. You can have your asynchronous communication forms, where you have your mailing lists. We all love them, don't we? Forums, but then also more synchronous ones, like a simple chat. So maybe Slack, maybe Discord, maybe you're still on IRC or Matrix, or a voice chat. But these really serve completely different purposes. So my recommendation is, if you are building up your open source project or you are participating in one, you should have one of each. Don't have 5 different places, because people will land in the wrong one. At least someone will. So really just have one. Also, issue trackers, bug trackers, etc. PP. Nowadays, that's mostly GitHub, but there's also other things for that. Hopefully not Jira. If it's Jira for your open source project, I don't envy you, but you do you. And as I said, have really one place for everything. So have one chat. If you want to do voice chats and video chats, you can do that, but really take into account that people come from very different backgrounds. They come from very different time zones. If you want to do voice chats, you might run into people who are sitting in a rural area and their internet connection is really bad. And if they are going to join a video chat over Jitsi with 10 video streams, their internet connection is going to crash. So maybe don't do that for important decisions. Especially synchronous communication always excludes people from the other side of the world. And that's still a big problem. So if you want to try to keep most of the discussion asynchronous so people can follow up when they want. And when it comes to communication, try to avoid ambiguities. So there's many people, unfortunately including myself, who try to be funny. And if you say, so for those of you who are fortunate enough to enjoy English education and maybe watch a few English shows, you'll know the phrase, yeah, right. If I pronounce it like that, it's an affirmation. If I say, yeah, right. I'm being sarcastic. If you if your English is maybe not so good because you didn't get the opportunity to learn it at school, or because maybe you had to work instead of going to school, then I already lost you. If I try to put that in writing, well, all hope is lost. So don't do stuff like that. Try really to be as unambiguous as possible. It can be hard. And also really, so try to keep your communication simple. And usually what's always a good idea to just assume good intentions. Most people aren't actually bad. There's always there. I mean, you get your rotten apple, but frequently people don't have bad intentions. You can just if you assume that they are maybe you misunderstood them, usually stuff gets resolved. So try to be kind to each other. That usually gets you very far. But how do you make really a community welcoming? And I'm going to suggest something that people might not like, but codes of conduct are actually not evil. It doesn't mean that you are going to enforce rules for everything and say you have to communicate in exactly this form, and if you deviate, we're going to throw you out. A code of conduct really can mean be kind to each other, assume good intentions, but it also means if you decide on something like that, which you should, you have to enforce it and you have to live by it. If you just slap a code of conduct in your repository and don't do a thing about it, it's not worth the paper, but you get it. It's really not worth having it at all because it's not going to do a thing. So if you want put down some rules, how you want people to communicate in your community, how they should behave, or how you want them to behave, and live by that and enforce them. And to have a nice community, you want to provide a place where they can meet, where they can talk. So that can be a chat room. You can also have video chats, but then again, time zones unfortunately make this complicated. And also what I would recommend for all things to document processes. Documentation is really king. Unfortunately, no one likes to write documentation, including myself. But I mean, sometimes I do, because documentation really helps, especially when it comes to community processes, when it comes to code review processes. Because if let's say you get a pull request for something and suddenly disagree. Especially bad if two maintainers suddenly disagree. Who gets to decide? If you have a rule written down, you can point to the rule. If it's just via some, well, usually we do it like that, people will start to argue. So if you can avoid somehow for people to argue over often very stupid things like code formatting, that's something that programmers often like to argue about. Just use a code formatter. It decides for you. If you can document rules, if you can enforce them, preferably automatically, that's always a net win. But please don't try to solve social problems with technology. That doesn't work. Technology can help, but technology will not solve people problems. You have to solve people problems with people. As a maintainer, you should always, or as a community member, try to be present and try to be friendly to newcomers. If you tell a newcomer to RTFM, you're not going to see them again, unless they really, 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 really want to use your project. But nowadays, there's so many projects, they're going to use something else. And help newcomers to do what they came to do. So as a maintainer, you might feel like someone comes in and they could solve a problem. Yeah, but I mean, I can do that in like 1/10 of the time. Don't. If you'll help them, it will take you twice as long, but they might stick around. And in the long run, that will be a win. They might stick, they might not stick around, but you'll never know if you never try. So what I'd also like to cover is a little bit, why do people actually contribute to open source? because if you understand why people contribute specifically to your project, you can make them stick around longer. Or also, if you're yourself looking for a contribution and maybe need some reason, you can find a few. So I mean, some people just contribute because they believe open source is the right thing and closed source is the highway. So let's take my way. Some do it just for altruism. People also just contribute for fun. That's I mean, yes, coding actually is fun if you don't spend all day in Jira. Some just do it for kinship. So you like the community and you want to contribute to the community and do it for them. Or just for your reputation, because I'm the one who solved all the nasty bugs. Reciprocity, so you feel the duty to just give back. Maybe you use this project for your day job all the time, so you feel the need, so you feel like it should be, you should also give back to this project. It's also a great learning experience, so that's most certainly a good way. Or the good old scratch your own itch. So if you found a cool project that doesn't do exactly the one thing you needed to do with open source, most often you can tweak it. You can use it as a career starter. I mean, I'm a software developer at SUSE, and I don't know exactly the reasons why I got hired, but I'm pretty certain open source contributions didn't hurt. And nowadays, many people, including myself, are fortunate enough to get paid for doing open source contributions. So that's also a motivation. Now, please don't get scared. This terribly looking graph, which you can kind of see it. I stole that from a paper. That's also going to be linked in the presentation. So if you want to keep your community engaged, you have to know why are they contributing. And you also have to keep in mind that this can change over time. So this graph shows you on the, do I get them? This thing has, I think, okay, this side of the graph shows you the initial motivation. So this has been a questionnaire for why people contribute to open source. And this is the initial state when people started contributing and how it evolved over time. So I think the questions were essentially, why did you start contributing and how is it now? And you can see a few things. So for instance, the scratch your own itch decreased by a lot. But many, and also learning decreased a little bit. But people kind of stuck around for, so fun increased, reciprocity increased, altruism, and at least in my opinion, the takeaway from this is that many people stick around either because it's fun or because they like the community. So if you want people to stick around, make your project a fun place to be and a nice place to be. Keeping people around because they'll never be able to scratch their itch, I don't think that's going to work. But you can try, but I don't think that's going to be that's a viable way. But again, every project is different. So, and finding out why people contribute, well, you can try asking. Maybe they'll tell you. But I wish I had a magic recipe for that. But unfortunately, I don't. A nasty thing, unfortunately, is conflicts. So in your community, you will inadvertently have conflicts unless you are only one person. But once you have more than one person, there's going to be a fight at some point. With fewer people, it might take longer. With more people, you'll get them, unfortunately. And I would really suggest that you try to resolve conflicts given your rules that you've put down. Because otherwise, if you just let the conflicts kind of linger on and fizzle out, people will build up resentment, and either they'll start to avoid each other, and you'll get silos in your community, which is always not fun, because then they'll start doing their own things. And also, if you get conflicts more often with one person, then the famous phrase, one bad apple can spoil the barrel, Unfortunately, it's very frequently used nowadays to say, yeah, you shouldn't judge the whole thing by just one bad apple, but the one bad apple can really spoil everything. So if you have a bad actor in a community, you should eventually think about removing them, because they can poison the whole thing. So with that, I'd like to switch more into the path of a maintainer. So if you find yourself to become an open source maintainer, one of the most valuable skills is, I think, that you should learning to let go of things and to share responsibilities. If you can't do that, you're going to have a bad time, because if you hoard all the issues for yourself, you can do that maybe for some time, but eventually just the psychological burden of having all of this on your mind and I have to take care of that, it's going to burn you out. So try to share your responsibilities, try to share your tasks, because actually what studies have found is that if you give people the rights to contribute to your project in a more meaningful way, like they are allowed to accept pull requests, they are allowed to merge them, their contribution quality will go up. So if you want to have a better project, share your responsibility with that. But unfortunately, as a maintainer, you also have to do the boring parts, like take care of infrastructure, write documentation. You'll be doing that a lot. So documentation is unfortunately never enough. That's not an excuse to not do it, because no documentation is even worse. Unfortunately, people will still not read documentation, but again, documentation is still king. So you'll also be covering the onboarding process and mentoring, issue triage, merge requests, maybe find cache because infra doesn't pay for itself. You'll have to, if you have a forum, you maybe have to do moderation of the forum. You'll have to debug why your server suddenly stopped working, why your CI stopped working. And if you're very lucky, you'll also have to start looking into licensing, do all the fun managing stuff. But maybe more fun things like making your project more popular. Because your open source project, unless you're the lucky person who found exactly the one thing that everyone needs, like, I guess, Docker or curl or SQLite, which are literally everywhere and are something that people really need. Getting this one lucky project, you will have to do very little marketing yourself. But if you're not that lucky person, you would have to do marketing. And as a computer scientist maybe, or as a programmer, you think, talking in front of people. Nah, but otherwise, if no one knows about your project, no one's going to use it. So if you want to make a project popular, talk about it, write tutorials. And what also works, if you're trying to solve a certain problem, find projects in need and send patches. Maybe they'll accept it. You might have to be persistent, but maybe they'll start using it. And over time, popularity will grow. And as I said, did I mention documentation? Write it. And making your project popular has also another advantage. So this is Mike McQuaid's contributor funnel, slightly adapted of the sales funnel. But the idea is essentially, if you want to have more maintainers, the one most common path to becoming a maintainer, you start out as a user of some project, then eventually you get sucked into becoming a contributor, and then you get sucked further along the funnel and eventually maybe become a maintainer. But the ratio between maintainers and users can be, I don't have numbers, but I guess it's in a best case scenario, it's maybe going to be 1,000 to 1, but I guess it's more like 10,000 or to 1 or even worse. It really depends on the project. So if you want more maintainers and you have 5 users, you're not going to recruit more maintainers from that. So make your project more popular. How do you do that? So this is from a study from Mozilla it's I think from 2007, so it's not super recent, but they reviewed how you get people on board of the project and what the influences of certain factors are. So essentially the x-axis shows you the impact of a certain property on onboarding, and the y-axis, that's just certain factors. And what you can see is that what really has the biggest positive impact is the perceived future impact and the recent volunteering experience. So really, if you want to get people on board, the vision matters. What actually doesn't matter is the past impact at all. So if you want to onboard people better, you have to give them a vision, and what they did, how much impact they had in the past, isn't really that important. What matters to them is that they think they can impact it. I mean, if you just give them the impression that they can have some impact and they won't, they'll eventually find out. But if your project has a vision and has a path to improve it, you will be able to get more people. So give them a vision, and also what this study found out, that if you have a great onboarding experience, it will motivate people to also onboard others. And another thing, if you want to keep contributors, especially for code contribution, quick responses are very, very important. So that's also from the same Mozilla study. They did a review of how long it takes someone to respond to a pull request, and they found out, okay, so if the maintainer responds within 24 hours, there's to a pull request, there's quite the likelihood that the contributor will stick around, or that they will work further on this. If it takes you longer than a week, the chances are 0. But it doesn't necessarily mean that you take the time immediately to review the pull request. It can also just mean, hey, sorry, it's my weekend, I'll take care of it on Monday. Or I'm traveling, sorry, my internet connection is like super horrible, next week. That's enough. But just answer them. And I know it sucks because it means you have to might have to check your work emails on the weekend, unfortunately. But really, if you want to keep especially newcomers around, you have to be quick about this. And a big thing for being a maintainer or also an open source contributor, really take care of yourself and don't burn yourself out over this. So stay true to your motivation and why you started contributing. And if it stops being fun, stop. I mean, even if you get paid for it and the project turns into a toxic dumpster fire, talk to your manager and tell them this is horrible. Because you must stay your top priority as a maintainer, as a contributor. If you're just gonna start, if it's just going to stress you out, and the thought of opening your issue tracker gives you cold sweat, it's not going to work in the long run. You might be able to force yourself to do this for just a while, but it's not going to work in the long run. And another thing that I'd like to quickly cover is feedback. And as we all know, maybe feedback in open source can be challenging because people often come only when things don't work. But then again, all feedback is still a gift because you get feedback from people from vastly different backgrounds that might have read your documentation and misunderstood it because you thought you said A and they read B. So still take it, thank everyone for it, absorb it and reflect. And really, in most cases, feedback is not an attack on you as a person. It's just something that people tell you. There might be people who just are nasty assholes and they like to tell you that you suck and your project sucks and more things that I don't want to have on a recording. but really don't defend yourself. Try to absorb it, adapt to it, and if it's appropriate, discuss it. But don't take it as a personal attack that you really have to defend yourselves from. But as I said, unfortunately, very, very frequently, but I think things are changing maybe a little bit, you mostly get negative feedback on none at all. So it's often very hard to get people to actually tell you what they want, what they are missing, or to test beta releases and similar things. People come to you when their stuff's broken, unfortunately. And that can be very frustrating, can be very crushing, because you don't see the 10,000 happy users. You see the 10 who are unhappy and come to you and dump in your issue tracker. But then again, you don't have to address everything that you receive, because there's also there's stuff that you can't react to. And really not getting bothered by this is something that you just have to train. So I've once had the opportunity to talk to Daniel Stenberg, the curl maintainer, and I asked him about this. How do you do this? And his answer was unfortunately a little bit, he just told me, yeah, well, I just don't get bothered by it, which as someone who is not a great open source maintainer and struggles with things like that, I'm, okay, damn it. So, but as many things in life, you can train them. And given that I only have 2 minutes left, I'm going to do my favorite thing. That's one to skip a few. If you provide feedback, I thank you, never hurt anyone. So thanking someone when you write a bug report, it never hurts anyone. And people will be far more happier. I hope this didn't discourage you. So if you didn't start your open source journey, you can start now, or please start now. But if you're building something, maybe wait until it's kind of ready. It doesn't have to be perfect, but marketing still tells you the first impression counts. So the first impression should be really good. And if you think this all sounds very, very terrible, it's actually not. It's still always a lot of fun. You can learn a lot. But only stay in projects as long as it is fun. And yeah, well, I told you this. No, I didn't tell you everything that you didn't learn at university, because we all still learn. But I hope I gave you some a starting point, some food for thoughts. And if you need more, there's the great collection called Uncurled from Daniel Stenberg. This is the paper I mentioned for motivations for contributing. That's a link to the study from Mozilla and the open source contributor funnel by Mike McQuaid. And there's my slides if you want to find them, or you can just grab the QR code if you have your phone at your hand. If you have any questions, I'd be more than happy to answer them.
I have one.
Yes?
So how did you start? What was your entry point to the open source community?
So I started, I'm not sure if I started first contributing to Fedora, or I started, so really code contributions were to a C++ image parser, which had some, where I just found out, okay, it got, someone found out that if you run an ancient C++ code base and you use AFL to fuzz it to hell, you'll find about 100 bugs in an hour. And I started fixing them. And eventually did all the mistakes, like hoarding bugs and trying to fix every problem myself, and eventually burned out. So that was a great example how to not do things. But that was my start.
How experienced you was in programming at that time?
I was already, at that point I thought I was fairly experienced, but it was, I already had my master's degree, so I think for like a month or so. But then again, I studied astrophysics, so I learned coding on the side to write simulations. Okay, then thank you for your attention and enjoy the nice weather outside. Thanks for having me.
Okay, can you hear me? Okay. Yeah. Okay. Okay, thank you all for being here. So, no, this is not working anymore. Should I turn it on some way? Yeah.
Click
Yeah.
on it and it should switch to the next slot. Okay, it's not switching.
Not anymore.
Yeah, is it plugged in?
It's,
Is it plugged in? Is the receiver plugged
Where
in?
should it be plugged in?
yeah,
The receiver is plugged in. Should we turn
Okay.
this on?
Turn up the phone.
thank you. Well, it was working, but it's stopped.
Maybe it's out of batteries.
Okay,
Yes.
thank you so much. Okay. No, there is something with my laptop, but okay, doesn't mind. Doesn't mind. Thank you. So, oh, yeah. So, oh. Hmm. Probably this is the cause.
Try the keyboard.
You can try again. Yes, no, sorry all. Okay. My name is Maya. I can say that I'm passionate about home automation, probably because I worked in home automation sometimes for a while. I also have a sort of smart home. And most of all, I believe that we can improve home automation. And what you will see in the following slide is almost this. What are the problems I see in the home automation systems today? How I'm trying to solve the problems I see in my way. And in the case you want, how you could use this my pet project that I'm trying to present you. And this entire talk is about a smart, just on-off, nothing else than on-off light. I mean, a switch. And this is my first question. Why do I buy a switch to put in my kitchen? So one reason is when I cook, my hands are dirty. Outside it's dark, and I don't want to switch on the button. My system should be smart enough to turn on the light automatically. But sometimes, even though outside is dark, I need, for some reason, I don't want my light to stay turned on. And I want to be able to say to my system that it should leave the light turned off, even though outside is dark. And in the very same way, when it's bright outside, I always forget to turn off my light because I don't realize that the light is on. And I want my system to do it automatically. But again, sometimes maybe I'm working in the darkest corner of my kitchen, and I want to tell my system, okay, now let the light turn it on, even though it's bright outside. And I want to be able to force my light to stay on. And another way to say what I'm saying is this. What I want is a state machine. It's a quite simple state machine. It has 4 states, and in this case we are managing 6 events. And I can explain a little maybe what's the, for example, what is this first event we are managing. I mean, my system thinks that it's a good moment for my light to be off. It receives a motion event, and it could be that it changes my light to off or on. It depends if it is dark outside or not. And maybe we can spend also 1 more minute on the forced events. We can go from into a forced event starting, if my light is for the system is off, then I can force it on. And if my light is on, then I can force my system to an off state, to a forced off state. And one more thing could be, how can we exit from a forced state? We can use, again, the same push button. So we are forcing it off if we are in a forced on. Sometimes I use also the events to exit a forced state. It really depends on the state machine you want for your device. And that said, my next question is, how complex it is to find a reuse, for me, such an obvious automation? And I try to answer the question using Home Assistant, which I think that most of you know, but for the one that don't know this project is nowadays, I think, the biggest open source project we have. And yes, so I'm looking something for Home Assistant, and this is the closest solution I was able to find. This is not written by me. I found it Googling for a solution for my problem. So we now go through this code. It's not so long, but let me tell you something about this. First thing is, we are reacting to a trigger. And so we are managing an event, but we should guess which event we are managing. And probably this is a motion event, and we can guess this by reading the name of the devices which made the trigger. And when we have guessed that this is a motion event, the next thing is understand which will be the state of our light. And the state for our light will be a non-state, because we are calling a service that says turn on my lights. Turn on my kitchen lights. And then we are also saying that we wait for another kind of event, and again is an event regarding the motion. This time is a no motion event, and in this case the final states for my lights will be an off state, because we are calling a service which is light turn off. So in this script we are dealing with two events and two states for the lights. There is something more. These guys also has designed a forced on state, some sort of forced on state. And he used for do this an input boolean. An input boolean is a graphical, is an entity in Home Assistant that you can use. And it named this entity kitchen light override. And when this kitchen light override is selected, then what we get is we turn, when the input boolean is selected, then we turn off the automation we have seen before. So we don't care anymore about the motion. And we said to and also we say to the system, okay, turn on my kitchen lights. So we disable somehow all the logics behind the motions. And this is almost the same, but it's the default case, so when the input boolean is not selected. What are the problems I see here? I can summarize them here. I think that this automation is complex to be reused. It mixes together the states, the events, and the triggers. The triggers. I have already said that we need to guess which are the events we are reacting to. We need to somehow guess which are the states for our final light. And this is more visible when you have more scripts that then take care of the same devices. And also another thing is, in my mind, when I think to a forced on state or a forced off state, I don't think to use another entity in a user interface or maybe another push button in your room. I mean, I have a push button that can control my light. I want to say to the system, okay, now I'm forcing you to behave in a different way with just that push button. And one more thing here is not listed. All we have seen was dealing with just 3 events out of the 6 I need. This is another problem I see. We have this light automated, and to the end user, the automated light looks like this. I mean, it's like any other non-automated light. I don't really think this is much useful. How can I tell if someone has forced my light or if it is just turned on because the system knows that it should be turned on? And if I want to force it, you probably can say me that I can put here near this widget, the other widget, the input boolean widget. But if I am the one that has written the script, probably I can understand it. Otherwise, maybe that's not the case. And it's not just a matter of widget. It's, I think, much more a matter of models. And I try to explain you what I mean with this slide. Here we can see the history of light. Here, sorry, is in Italian, but the first row, it means turned on. The second row, turned off. The third row, turned on. And the last one, turned off again. And I wonder if someone finds this useful, really useful. I mean, I never look at this kind of history because, okay, I can say that my light has been turned on for a while. Maybe I can say it's more than I need. But behind my light, there is much more, I think. I want to be able to see yeah, all the other events that can make change this light. So for me, this model, this just on-off model, is not helping you and the others in your home understand what is going on. And I think this is the cause. This is taken from the Home Assistant website. And I think the really interesting sentence is the first one. I mean, yeah, this one. Home automation itself has never been a goal of Home Assistant. And I think that the point is this. Home Assistant is, as all the other home automation systems I know, are thought to let you control your devices, not really to automate them. And if you remember in the slide we have seen before, there were a big there was a big focus on the voice control here, because Home Assistant is putting a lot of effort in making you control your devices in just another way, using your voice. And that's their goal. So you can say to me, but we have a rule engine in Home Assistant and we can use it, and that's true. But what I think is that these rule engines are designed to let everyone, almost everyone, create simple automation in a simple way. And to answer my own question, if I think there is enough automation in home automation, I think the answer is no. And I think that the reason is why we haven't the right tools for doing proper automation. I mean, complex automation. So, in this second part, I would like to show you what I think could be, what kind of solution I have, almost working at my home. And yes, let me show you. So, here are 3 switches, no more than switches. But you can see that the second one is not in an on or off state. It has another state, the forced state. And this is something that knows just the system, not the device itself, but for me that's enough. And near the state, there is the events it receives, and that makes the automation change. And you can also spot that there are different events, so this means these are all different automation for the very same kind of device. And this is, again, a history for the very same device as before in the same time. But this time we can see something more. We can see that the second time the light was not just on, it was forced on. And also we can see that for a while no one was there. And since it was forced on, the light stayed on since someone unforced it. And few seconds later, someone walked near the light and it turned on, but this time was the system to turn it on. I think that here we have some more information. And yeah, another thing I can interact with the automation I create. And this is not really something that I use every day. I mean, this is just useful if you want to debug your connection. I mean, when you connect your automation with your devices, or maybe when the system, for some kind of reason, goes out of sync. Maybe it was just shut it off for a while, so the system. Okay, this is not something I need every day, but this instead is something I really use. And this is something that lets you change your automation accordingly with your needs. What I'm saying here to the system is stop managing the brightness event. Behave like if outside is always bright. And in this way, this automation will end up not turning on my light again automatically, because it's like there is always bright outside. Maybe this is not the best example. I probably use this feature more with other models, like the blinds model or other kind of devices, but I think that be able to adjust the automation to your needs, because your needs changes, it's something really useful. And to summarize it, which is the difference between this project and the other projects I know. The difference is that I write different abstract state machines for every automation I want, and this state machine become the model of different on-off lights, which are all the same device. In the other home automation system, all the lights, all the same lights, have always the same model. And now we can go through an example of how to use this project. So the first thing you need is to choose your automation, choose your model. So for example, I have put here two models, the kitchen model we have already discussed, and another simple model like state machine I could use for an outdoor wall light. And after you have chosen your model, you can put it down. So you give them a name, and so like this. And then what is missing is how to connect these abstract state machines to the real devices. And here I'm doing this. So my wall light, my outdoor wall light is a KNX device. So I'm saying here that this command is able to send an on command when the state for my abstract state machine is on or forced on. And is also able to send an off command to this address, which is a KNX address, so no internet address, just something different. And yes, it's able to send also an off command when the state is forced off or off. In the same way, we need to send to the abstract state machine the events. We need to say which are the messages on the bus that trigger some event. So, for example, messages to these multicast addresses can be mapped to a forced event on if the command inside the message is on. Otherwise, they can be mapped to forced off if the command inside the message is off. And in the same way, we can connect the kitchen light. In this case, I don't know which kind of device I have behind my kitchen light, because I'm connecting to it using Home Assistant as a gateway. So I just know how to, which is its name for Home Assistant. And in this case, the commands can manage just or the on, in this case, or the turn off. So I need both of them to be able to manage the on, forced on, off, and forced off state. And in the same way we have done before, we need to map also the messages going through Home Assistant that triggers a forced on event and a forced off event. And after I have done this, I can put together my two lights. This will be used later. I need for the kitchen light to manage also the motion, no motion events. And here I sending this kind of events to my state machine. So, in this case, again, my motion sensor is a KNX device sensor, so I'm listening to a KNX address, and I'm mapping this message to an event that has this name, but maybe can be improved, but it's like motion event spotted. And in the same way when we have no motion anymore. And this is quite simple, I think. This is more complex. How can we deal with the brightness? I mean, it is simple if we want to just the simple solution brings with it that if a cloud across your sky, then the light will turn on. Otherwise, it will be turned off. And I don't want such cases, so I need an integration of the data. For this, I need a scheduler, and this is why this example is a little bit more complex. So here I'm collecting the data that are coming from a sensor, again a KNX sensor, and are data of light. And I'm using these two triggers that says, okay, this is, this is greater than this value. If the collected data is greater than that value, then send to the state machine a brightness event. And this is saying if the collected data is lesser than this, then send to the state machine the dark event. And and we need to schedule it to collect the data, analyze the data every 60 seconds into the scheduler. And we do this like in this example. So we are scheduling the triggers, which will send their events to our state machine through the performance.
What is the peak value? Previous slide there was a peak value.
Sorry?
Peak value, 40,000 and peak value.
So these are looks, I think. Yeah, you can, this trigger don't really know the value you put in. So you can put everything, but my sensor is measuring looks. So these are looks. And this is done. We have completely automated both the lights and all the events for all the lights. So for one light, 6 events, for the other light, 4 events. And probably you are wondering, what about building your own model? You need to be a developer because models are written in Python, and our state machine written in Python. But at least I think that they can be reusable. I try to make them understandable using BDD, testing them with BDD, and using BDD you can then read their behavior. And yes, at least this. Which is the difference between from another point of view, which is the difference between Home Assistant and this project. In Home Assistant, you have your physical device already modeled, and you write an automation around it. In this project, you write the automation, and then you tell to the system how to interact with your automation, how the physical devices can interact with your automation. And I know that this can seem boring, but I really like this feature because it really gives you a lot of freedom. I try to do just an example. I have these blinds. They are not outdoor, are inside my room, but I have no sensor inside my room for detecting when my windows are open. So, or I give up of using any kind of automation because it's too dangerous to close automatically the blinds when the window is open. Or I can have an automation, a complete automation, and just say to the automation that it can only turn up the blinds. And this is what I'm doing. I never connected the down command for my blinds in my automation because it's too dangerous. But the automation works perfectly with all the other states when it comes to move up the blinds. And here are the links related with some example for the project. And what next? If you want, try it out. Let me know what do you think. And if you want, you can improve it.
Can you go back to the links? I can't type that fast.
And yes, so now any question?
One of the things in my own home automation, you talked about states and events, and like the things in Home Assistant are very much basically edge triggered, like the motion example. What I really care about is presence. Is someone there, which isn't an event, it's a state. And like the triggers are all very much based on, did the motion thing fire or not? So I'm experimenting with setting up a system where it basically has the primary thing is a state. Someone is in the room, or the sun is up, or something like that, and then having triggers sort of be information that can feed into that state. Have you thought anything about that kind of linear model?
I'm not sure I got your question. Okay.
How do you detect the presence? Motion can be detected?
So if you just have an IR motion detection, you can kind of assume presence if there's been motion recently. So what I do in mine is I basically have it's a non-binary thing. I'm old, so it's fuzzy logic instead of neural network, whatever, but it's basically, when motion is detected, there's a 100% chance of presence, and then it goes down decays over time, and then I have a threshold where it's like, okay, probably no one's there. Because my wife did not like the lights going off on her in the kitchen all the time.
Yeah. If I understand your problem, I don't like to turn off my light. In the kitchen state machine, sorry. It's
I guess a semi-related question. Well, first of all, are we supposed to flee the alarm?
My colleague went out to check if it's a real fire alarm.
Okay.
Hopefully it's just...
I guess we should probably
go. Okay.
please proceed orderly to the exits. Attempt not to trip over the ridiculous chairs.
Yeah.
So, what I was going to ask, for your Windows situation, I understand the problem. So I have a window sensor that tells me if there's something or not. How easy would it be if you go and buy a $10 window sensor to add that to your model? That you have an existing model and you add a window sensor. How easy is that?
Oh, sorry. To change.
Yeah, you've created your blind thing, and now now it's got this extra. I can now tell the windows. How easy you reprogram it now? Does it change all the things, or is it
Okay. Hello. Hello and welcome to this talk. It's called Open Source Automation, Struggle Between Comfort, Openness, and Usability. I will have a few questions on you. Does any of you have been on my talk last DevConf in person? Nobody? Amazing. Are you familiar with Home Assistant? Hands up, hands up. Amazing. Have you ever heard about ESP.io? Have you ever heard about ESP Home? Amazing, amazing. So let's start. Thank you very much for coming. So who am I? My name is Tomáš. I'm the bald-bearded but barbarian from the east. I came from Slovakia and I moved to Czech Republic about 15 years ago. I considered myself a software engineering grease monkey. What does it mean? I worked as a software developer for about 15 years. Now I do operations, system administrations, and software development on the side. And my motto, somebody gave me a sticker on this year's FOSDEM, and the sticker said, I can write my own 0 days, thank you very much. So this became my motto. I live by it. I can write my own 0 days, and I did it on numerous occasions. So what's the motivation doing this talk, and what's the motivation even like doing home automation and smart homes the open source way? So the biggest is privacy. We all know, as I talk about the struggle, we all would like to have those devices that you just connect at home and they work and they are safe. They do not steal your data. They are not spying at you, and the software engineers did a good job. I'm not sure how many of you are software engineers. I am, and I don't trust software engineers because I make mistakes. Everybody makes mistakes. So I pinpoint one thing. This is a picture coming from a relatively recent paper, which is from German and Netherlands universities and the cooperation. Those two universities, Max Planck Institute and some other from Holland. I'm sorry, I don't remember the name. So what they did is that they tried to buy a bunch of those smart connected devices and connected them to the network with IPv6. You know, it's that amazing new technology. It was invented in the year 1998, right? And nowadays, still only 30% of requests to Google are over IPv6. This is a great example. They took a bunch of smart TVs created in the years 2019 till 2022. Most of those devices have implemented the standard from the year 1998, meaning they were able, they created something which is called extended unique identifier, which means that in the first implementation of IPv6, your MAC address was part of that address. So you buy your TV from a renowned company, and you connect it to your internet, and then you realize there is your MAC address. There is your address space. Huh, what happens? You can be tracked. You can be tracked. Amazing new technology. Nobody did anything wrong. They just forgot to read the documentation, which was released in the year 2000.
Just to check, it's a typo if the tracking ID doesn't match the DevConf or the laptop?
So, you mean here?
Yes, the laptop.
Yes, because the laptop uses privacy extensions for IPv6. So it has randomized the part of the MAC address, but you still have on your network that one device which is identifiable. So, hey, it's the same network. It's the same guy. This TV, his computer, and here goes the advertisement revenue, right? So this is just one of those examples. It's a really nice one because it's a relatively new one. The others, you may have read the news. Amazon got fined $30 million for privacy violations of Ring cameras. And there is much more every year, and we will see much more every year. So that's why. I started this project about 5 years ago when I bought my house and decided to make it connected to everything. So this is how I started. I started with simple Home Assistant installation with the PostgreSQL as a database and ESP Home as a building block for all those sensors and cameras and all connected stuff that I have. This is where I have moved. This is 3 years later, so it's about 30 environmental sensors, about 20 presence, bunch of cameras, and I have added it. I have removed some stuff from the stack. I no longer use Postgres, and I have added a new framework which is called Tasmota. I'm not sure how familiar are you with it. I will get back to why a little bit later. And this is basically where I got regarding the connected devices that I have at my home. All of them except 6 are handmade by me. Others I bought and flashed with open source software. So how did I get here? So from one Raspberry Pi, which I experimented with, to cosplaying as a sysadmin. So now I'm running 2 firewalls, 2 storage nodes, 2 virtualization nodes, 2 everything on the double, because I want to be sure that my house is always connected. And I can rely on me flipping the switch and the pump going on. Or the more important thing, when I flip the switch, it goes off. So I moved slowly but surely from Raspberry Pis. This is the Raspberry Pi 4, but I started with 2, which was 32-bit ARM. I'm not sure how familiar are you, but 32-bit ARM was a mess. So I tried a number of boards. The performance was not there. It's fine if you are experimenting with it. When you have small networks with dozens of devices, it works perfectly, nothing to fear of. But the moment I started to grow, I realized that, okay, what will I do? Let's try new hardware. So I tried one of the first 64-bit ARM boards, which is NVIDIA Jetson TX1, which was widely available. And run the Home Assistant on that sufficed for some time. But then you hit the bottleneck, as with most ARM board at that time, which was storage. It only had one SATA port, which is slow. SATA is 6 gigabit. It's really slow storage nowadays. So I moved to standard hardware, like PCs, x86, 64 machines, nothing fancy, just the consumer-grade hardware, which I bought from the shop, put it together, deployed stuff. And over the time, my wife started complaining because you can see there are 3 nodes. There was another 3 nodes just lying on the ground around the house. So I decided to optimize and start playing as a sysadmin. So I bought my first rack, built everything in it, and it didn't work. So after a bunch of debugging and redeployment and understanding all the underlying technologies, I choose to use TrueNAS as my storage server, which is a really nice open source project. The scale offering from them is based on Linux, so no BSD needed. It does replications, it does all the magic for you, and you don't have to do a thing. Podman for running some of the infrastructure-related things like databases. I do InfluxDB now, so running Influx, running some pipeline for image recognition. That's why you can see a bunch of graphics cards there. To be honest, I have to admit, the picture is from the times when I was mining. But I still have the hardware, so why not to run something useful on it, right? So I started to play with different things. So let's get to for what I started using compared to my previous solutions. In the first talk at DevConf like 3 years ago, I presented different set of sensors that I was using. But over the time, somebody pointed out some other sensors, like the MH1, which is CO2 sensor, which is basically a replacement unit for some AC something. But you can buy it relatively cheaply. It's a relatively good CO2 sensor. Then there are a couple of Bosch sensors, which is environmental sensor and sensor for illumination. So I can tell if there is enough light in my rooms and if I need to turn the lights automatically on. And the presence detector, which is basically a microwave radar. It uses a reflection as a means of identifying movement in its surroundings. I am really surprised how precise this sensor can be. If you have the right board behind it and the right piece of software, you can make it tens of millimeters precise, which is nice. And that will be it regarding sensors. The other thing that you need, I needed, and I wanted to work, was our displays. Sometimes you just need some information. You need to quickly see if, for example, the pump is half of its cycle. And I don't use smartphones, so I don't carry phone around my home. I don't always have a notebook with me, so having nice randomly placed displays that will show you some information can be really useful. I will just pinpoint a couple of them which are really nicely supported in the ESP Home platform. And those are the two small OLED displays. They are amazing, colorful, really nice, and really easy to work with. Then there is two of TFT displays, which are LCDs. One of them you can buy as a separate module, or maybe both of them. But the 7-segment one is used in some devices, such as this one, which is power metering device. And they are nice. They are colorful, but they are small. And they don't have really high DPI. This is 240 on 180, I think, or something like that. So really small number of pixels. And then I saw on the internet there's this nice IPS display that you can buy. It's 7 inches, costs about 35 euros, and it can do high DPI. So I bought it. And then I realized you need Windows to write the UI. And I was surprised here. My experiments with the next-gen displays end up because I don't run Windows, I don't run closed source applications, I have no way how to put the UI on there, but it's running ARM M3 Cortex, so there is some firmware there. I was able to get a serial console on it, but I wasn't able to flash it. My embedded knowledge is really limited. Even when I'm standing here talking to you, I do not know that much about embedded systems, but I know something. So don't be afraid of MCUs. I choose this platform as something to show you. I haven't had to do a bit of soldering to build these two things. Don't be afraid of it. You can just buy it. This is a platform from Chinese company that you can stack together. It has standardized connectors. You can just put it all together, write your own code, flash it on there, and play with it. It doesn't hurt, and it's really simple. The ESP Home that I was mentioning is basically declarative framework, which allows you to write code without writing code. So you need your YAML files, and they will generate the code for you and create all of those bindings that you need to the libraries that you are using, load all the drivers that you require. So they don't bite. And another thing that I have added to my smart home or connected home is a power metering. So these are those products that I don't build. Because working with mains power and switching mains power can be really dangerous. You can see a nice example of the danger here. This is not my picture, just took from the internet, but I used the same box. This was error of the user. He connected wrong inputs, but I have seen similarly burnout box, one of mine, when I used this device, which is the dual R3 from company called Sonoff, and they guarantee you 2,000 watts of resistive load. So I connected 2,000 watts of induction load to see what happens. Who would expect that it burned? Well, it burned really nicely. So this is really interesting bunch of products from the company called Sonoff, as you can see here. So what do? This is a line they call do it yourself. So there is a serial console. I'm not sure if you can see it. Probably not. There is always a serial console somewhere there. All of those boards have it. It's under the hood. Either they have just soldering pads, or they directly give you the serial console. And as we know, where is the serial console? By the way, so you can basically flash whatever you want there. I will mention all of those devices. So these two up here, basically the one on the right is an older revision that the company already stopped selling. I believe it's because of the circuitry they used, and basically it wasn't very well built for the purpose that it was supposed to do. It's about 5 months that they created an absolutely new version, which is called Power Free, which is the biggest box here. And this is really interesting because they listen to us, they listen to people who use their products, and they created a box which is able to switch 5 kilowatts of induction load, which is amazing. So what I did, I tried, and it works. I connected my 3.5 kilowatt induction load on it, and now it's switching, I think it's 3,500 cycle. I just automatically switch it every day a couple of times to see how long it will survive. I will definitely update my page once it dies, because I'm looking forward to see if they have learned something. Because one of those, the Power R2, used a really cheap relays. And after I did this test with them, with just about a couple of 100 watts, after 5,000 cycles, somewhere around there, most of the relays get stuck. And that's not something you want, especially if you are switching some load that can be destructive. So pumps and things like that. You want to have reliable relays and reliable switches. So these parametering devices, the newest one is probably the best design also because it uses CT clamp. So you can see that the measuring interface is basically outside of that circuit, which is not true in all of the other solutions by them. In all other solutions, it's directly on the board. There is some resistor which is used for measurement of the voltage and measurement of the current, but that can lead to fires. Doing it this way doesn't matter what you will put through there. If the cable does not melt, you should be okay. And I just mentioned 3 of the sensors that are used there. For those of you who are interested, they are basically one-purpose things to measure current differences and voltage differences. Go figure how and why they use those 3. The last one is probably the most precise one. Those 2 are probably the cheapest ones. So that's about parametering. So let's talk about how you connect those devices. So I never had any reason to do anything else than 2.4 gigahertz Wi-Fi. Because it was too expensive, I didn't see any reason for it. But a couple of years ago, there's this shop called Lidl here in Europe where you could get one of those boxes, which is basically a base station for Zigbee with some RTL, with some Realtek MIPS SoC and some Zigbee SoC. And so, me being me, bought it for, I think, 15 euros or something like that. I opened it, which you don't find. There is a serial console on there. So I tried. I played with it a little bit, poked around it. But as I mentioned, I'm not that good with embedded systems. And there was already somebody smarter than me, named Paul Banks, I think, who already did flash it. So I looked at his work, basically followed it, copied it, changed the configurations a little bit to suit my needs, and flashed it back with Alpine Linux, running my software, not contacting Chinese government data centers, and just talking to my stuff. But this device, and I bet it on the SoC, is not reliable. The network I created using this base station was clustering all the time if I connected more than 15, 20 devices. So it's decided to switch something different. So that this USB dongle, which is again from the same company as the parametering devices, and again, they put serial console over there, so you can flash it with whatever you want. And it's Texas Instruments radio based on similar chips, but it's stable. Again, the price is around 20, 25 euros. I have deployed 3 of those devices and network of 65 Zigbee clients, but I was unable to make it work for longer than 20 minutes. Every time I try to create bigger Zigbee networks at my home, they get clustered. They always get clustered, and I don't know what to do. And I don't really use Zigbee that much. I just wanted to test it, so I sold most of the stuff and left just a couple of light bulbs, and that's it. For the other radios that I use, that's Bluetooth. So I'm not sure if you're familiar. This is SpineWatch. This is Bengal.js. Those are open hardware watches, smartwatches that you can buy. You can flash whatever you want on them. They have Bluetooth LE, so they transmit a lot of information over the Bluetooth LE. You can get it. I use it for presence detection. So if I want to know where the people are in the house, actually exactly me and my wife, so where do we are, where do lights need to be on, when they can be turned off. But there is no direct integration for Home Assistant, so I had to use some other means. One of them was Room Assistant. This was a really nice project I found a couple of years ago. It's basically really simplified Home Assistant, which should be working on the level of rooms, but it has moved to be an abandonware. What it does, it's basically, for me, it was Bluetooth to MQTT gateway, which basically just transmitted the messages from the watches to the Home Assistant, and then I could kick in the automations and do the Home Assistant stuff there. There is a huge amount of implementation of Bluetooth to MQTT. Why? Most of them are just basically shell scripts, Python scripts around Bluetooth CTL. We just paste the commands and work with that. The difference is probably the Open MQTT Gateway, which is a project that has a number of integrations, and it does support a number of protocols. So you can use Bluetooth, LoRa, whatever you want. I have more or less dumped all of those solutions, and I basically use the watches, Home Assistant with its beacons, and that's it. Another part of the setup are new cameras. So probably the most prevalent that I have at home is ESP Cam. It's basically ESP32 chip with camera on it. I built a couple of housings for them. You can see there is an AC power. There is the camera. I prefer, when I put some mains powered things, I prefer to use this kind of boxes. This is electrical installation box. Why I prefer to use them? They do not burn. So even if you try to put them on fire, they will not burn, which is amazing. But soon I realized that ESP cams have a huge disadvantage, and that is the CCD chip that's on there. It is 2, 3, 5 megapixels, depends on which version you have. But for my use cases, which I will show you in a moment, it was not enough. So I played with Raspberry Pis. That's better, but still, if you want to take a picture of something which is more than 2 or 3 meters away, the basic Raspberry Pi camera is not really useful, because you will get you know there is a person, but that's it, nothing more. The great thing about using Raspberry Pi, is the platform. You get Raspberry Pi, this is the Mini, or how is it called, which is a really nice, small, single core with 500 megabytes of RAM. You can put Linux on there. It's nice. There is another thing that happened some time ago, again from the Pine64 company, which is the PineCube. This is basically Linux-based camera. So what they try to do is that they created a board. Problem for me, again, is the CCD. It might be enough for indoors usage, but for me, it wasn't good enough. And then we get the last thing, which is just something called IP webcam. And this is the logo of the application. You can find it on F-Droid. If you don't mind your privacy, you can find it on Google Play as well. And it's basically an application that gives you beautiful interface to a camera system. You can have multiple renderers. You can hook it into whatever you want. You can hook it into the automations in Home Assistant. You can hook it into different NVRs. You can do whatever you want with it, and you can reuse any old phone, which is nice. And phones have really nice cameras. So here you can see the difference about this is why I mentioned that ESP cameras are not enough. The one with the blue car, it's made by smartphone. The one with the red car, it's made just by the ESP cam, and you can see that the picture is not so much clear. Maybe you have noticed there is a bunch of squares there. So there's a yellow square. I'm not sure if you can read it, but it says car there, and then a percentage. How sure it is that it is a car? How sure it is that it is a car? And usually it's more than 60, so it works. As it goes for the software, I used Motion Project. It's a daemon for Linux that allows you to use any camera input and detect a movement on it and take still pictures, create a video. There's another project called Motion Eye Project, which basically encapsulates the daemon into the web UI. For a while, they were releasing Motion Eye OS, which was basically image that you could flash on a number of ARM-based boards, and it contained minimal Linux system and the UI. So you could just then hook it into the NVR that you already have, or use it as an NVR. And those boxes that you can see are created by this amazing project. It calls D0207. I forget what the acronym stands for, but it's the second version. There was one a couple of years ago. It's a really nice open source project because it provides you a REST API for object identification. So you just post picture there, and you will get, you run locally, and you post picture there and get a result back. So I'm running it on a bunch of NVIDIA cards, or I was running it on a bunch of NVIDIA cards. But then you realize that mining Ethereum is one thing, but when you want to process the images, you don't necessarily need a kilowatt of power to consume just to process a bunch of images, right? So I moved from experiments with graphics cards to just plain CPU work, which costs less. So the other important thing about having connected things is the way it notifies you. So this is a bunch of connected light bulbs. As I mentioned, I have got a bunch of the Zigbee ones. When you ping me on IRC in our Fedora channels, this is what happens at my house. So I start getting notifications because I work from home. Similarly, something similar starts happening in my office. If our Composys fails consequently in 2 days, it will start really blinking. And the other thing that I built, it's the wall thingy. I call it the wall thingy. It's basically the e-waste I found around the house and put it all together on one piece of board. It's a bunch of displays. One of them is currently off. It's a bunch of displays. You see, this is the Home Assistant dashboard that I use. This is my driveway, so I can see when the check post arrives, because they don't wait. And that's it. And that's basically it about the talk. So do you have any questions? Why do I need 15 cameras? So you can't see it, but there is a roe deer here, and I want to have them on the photos. So that's why I basically monitor only outside of my house. No cameras are pointing inward because I don't trust software engineers, so I don't trust myself. And only the cameras are only on outside. And I want to not keep track, but keep track about the life that's there, because I live at the end of the village, so I track the birds that are flying there, I track the other animals that are there, and things like that. And you know, those funny photos of your cats and dogs and stuff that you can get.
Have you ever measured the power consumption of the PineCube?
Of the PineCube? Not really. Not really. I always just power it, but I powered it from a really cheap power supply, something like I have here on the camera, which is really small, 700 milliamperes, I think, or something like that, and it booted. So I'm not sure about the exact power consumption.
The thing that you put, Wolfie, how much did you pay the marketing department?
You have to ask my wife. She is the marketing department. Are there any other questions?
Are you aware of BT Home?
Sorry?
Are you aware of BT Home, the new standard for Bluetooth low energy messaging and like checking presence and all of that?
No, not really. Not really. Can you please repeat?
BT Home.
BT Home? I will look into it. Thank you. Any other notes? I'm open to anything. If I was wrong, not correct, so just tell me. If that's it, thank you very much. Yeah.
Do you use some,
Yeah, no,
do you use some complex scenarios in your home? Like when I enter, turn light on, then coming out from home, turn light off, or don't? Or just
so not really regarding the house itself, but for example, my office where the wall thing is, so now it's turned off because I'm not at home. So yes, then some small portions of it, like for example, especially my office is probably the most automated part of the house, and then the garden, because there's a lot of work there. So yeah, if I walked out of the office and it's after 8 p.m., means I'm no longer at work, everything shuts down. And then in the morning, usually I wake up, the home assistant realized that my watches have moved to the kitchen, so I'm making a coffee and everything turns on, computer boots.
So the question is, how hard is support with scenarios?
If you decide to use this kind of do-it-yourself hardware, like those switches I have noticed, things like this, it's extremely easy. It's extremely easy because you just need to identify, let's say, person, you. Then you need those relays to switch the things. There you are. And Home Assistant is declarative, so is YAML. So you will declare in the YAML file how it should act, similarly to automation and Ansible, and it will do the things. Okay, thank you very much for your attention.
Something isn't right. Notebook.
Yeah.
Good.
I think you hit it right.
Okay. Ladies and gentlemen, I hope you can hear me well. Welcome. I'd like to start with a simple question. Who of you wrote some code? Please raise a hand. For those watching us online, welcome. If you are here, you would see every single hand up. And silly me, yes, it's DevConf, right? We are all coders, we all understand it. Now let me change the question slightly. Who of you intentionally wrote code which doesn't do what you want it to do? And the word intentionally is important. And I don't mean hacks, I don't mean some exploits. We have one. I guess you are a teacher, you wrote something. Yeah, you wrote something for your students, so it was intended so that it doesn't work. I have never met a developer who tries to write crappy code, but yet here we are. A lot of crappy releases out there, a lot of customer bugs. What's going on? Where is the disconnect? Should we blame the testers? Ladies and gentlemen, welcome. My name is Michael Chada, and this is my take on quality engineering mindset. And if we have time, I would like to look into testing breakdown structure to see some kind of questions and how to apply the QE mindset itself. We will talk about what QE mindset is not, what it is, and why it's important for the company to adopt. So let's start with what QE mindset is not. And I heard this more times than I would like to. It's rejecting responsibility. The I told you so mindset. You are a tester, you say, hey, this isn't right, something is wrong there, but hey, it's not a priority to fix. Then you go to production, something goes wrong, and you say, told you so. This is not what we want. We want collaboration. We don't want compromise. We want everyone to understand that quality is responsibility of everyone. And if you are not happy, if you see some risks which are there, don't stay silent. Narrow focus. And that is more true for some historical testing approaches where QE mindset is not about just writing tests, going through automation. It's about more. It's about the whole development lifecycle. Checklist mentality. You cannot blindly take standards and apply them to your situation. Every team is different. Every project, product, service is different. And just ticking some boxes, that might not be the priority which you currently need. You don't want to become a roadblock. You don't want the team to see you as someone who is holding us back, someone who is slowing the development down. I did a short survey with my friends and colleagues about what they think the QE mindset is. And all of these you see on the screen are part of the QE mindset, but I would like to touch some of these anyways and share some of their risks and limitations. So it's a mindset to deliver quality above else. Imagine a team writing an amazing product, something where quality is above else. They do everything properly, they have the best processes, is the most robust service in the universe. And then they go to market 15 years after the competition. Desire for things to be always better than they are. While that's true, continuous improvement is something we want. Sometimes good enough is good enough. passion for things to be perfect for the customer. And I would like to use a quote here. Don't let the perfect be the enemy of the good. And often we can have thousands of customers. And the perfect for one customer might not be the same what is perfect for another customer. Also, we might have a different vision of our product than what customers have. Attention to detail and critical thinking. And this is a good one because we can apply it to the whole development lifecycle. And yes, it's a strong part of quality engineering mindset. But also, sometimes you don't need to go as deep. Sometimes you need to understand the big picture, don't have a narrow focus. And the ability to understand and mitigate what can go wrong for a customer. We are back to our customers who sometimes don't know what they want. And yes, we want to predict what might go wrong. But quality engineering mindset is not just about our product. It's not just about our service. It's about our processes. It's about our automation. It's about our documentation. It's more. So how do we define quality? Users getting the intended value. Okay, but how can we verify that? Can we test our way to quality? Can we reach quality? And I would say no. I think it's similar to security, where you can test for known issues, known exploits. You can analyze where we are to what we know, but you can never say, hey, we reached security. You cannot breach us. And I see quality similarly. You can not really reach quality. And talking about quality, I think it's important to touch types of quality anomalies and to see that it really is a big picture. We are not limited to just bugs. We have functional problems, performance, security, usability, and many, many others. And in order to understand quality as a whole, it's crucial we focus on monitoring. You want to monitor not only your product, but you want to monitor your processes. You want to find where the bottlenecks are and how you can improve quality by focusing where the constraints are. Otherwise, your innovation will not be visible at all. And with this slide, I don't want to go into details here, but you can see that software quality field is really, it has its own history. It's almost 80 years old. And we started with code inspections, with first formulation and beginnings of some guidelines, testing maturity models, benchmarks, and we had this agile manifesto revolution with Scrum and Kanban, and last 15 years it's DevOps, machine learning, AI, and question for everyone. Where is your team stuck in history? Are you still doing manual tests? Are you doing checklists? Or do you already have DevOps in place? Do you leverage machine learning and other types of automation and AI? And you have seen that the evolution is there, it's very visible. And I feel like it's important to mention the evolution from QA, from quality assurance, to quality engineering. And there are three main differences in mindset, in role, in scope. For quality assurance, the mindset is really narrow. You focus on vulnerabilities, on verification, on writing automation. The role, it's usually done by a tester, or worst case, by PMs who are trying whether it works. And the scope is very limited. Whereas quality engineering is a mindset. It's something which should be adopted by everyone in the company. So the scope is the whole development lifecycle. And I would like to diverge a bit and talk about the primary objective of IT department and maybe go even one level higher. What is the primary objective of business? Well, in most cases, to earn money. How do we earn money? We deliver value to customers. And in IT companies, usually we try to deliver some products or services. And we would like to maximize our gains. And you can maximize gains by either limiting the costs or increasing the value, increasing the amount which you can deliver. And where limiting the costs has limit at 0, delivering the value, that goes only up. Well, not only up, but you want it to go up. There is no limit. So really the focus of IT department should be to make sure that our developers are as efficient as possible. So that the not roadblocks, so that the constraints, the bottlenecks are in development and not in our releases, not in our automation, not in our testing. And how can we achieve that? By implementing ongoing improvements, trying to make things automated, better, faster, by making sure that quality is really shared between all the roles, and by focusing on fast loops, fast feedback to prevent as soon as possible. Here we get to a definition I came up with, and let me read it. It's a bit long. So quality engineering mindset is a proactive and holistic approach to software quality that permeates throughout an organization. It encompasses a set of attitudes, beliefs, and behaviors that prioritize and promote quality at every stage of the software development lifecycle. Did you notice something? Isn't it a bit vague? Isn't it a blank statement? When you share this definition with a team, they say, okay, and what? Like, why should we do anything? It's only common sense. And I thought about it for a long time and realized that it needs to be vague. Because quality is not a solved problem. You cannot reach quality. You can just look for regressions, verify against the norms, and check out some other anomalies. So why is it such a big deal? Why we can see in the history the evolution of quality? Well, it's important for business. Everyone understands that you need to deliver good quality to our customers, otherwise you will not be successful. And I don't want to go deep into each of these fields. We have a lot: customer satisfaction, product quality, efficiency, productivity, collaboration, communication, etc., etc. It's a lot. So how can a tester make sure that you have quality in all of these? Yeah, it's simple. Testers cannot. So that's why we evolved from quality assurance to quality engineering mindset. That's where the tester takes a role of an ambassador of quality and not someone who just writes tests. Testers are educating the whole team and advocating for quality throughout the whole development lifecycle. And for testers, this slide is mostly for you, but others might find it interesting as well. We have some common pitfalls, and here's my take on this. we are under tremendous pressure. Features, features, features. That's all people want. We need to deliver features to customers. We need to deliver it fast, ideally yesterday. We don't have time for quality. What can we do about it? And I would argue that this approach already shows that you are not embedding quality in the development process. Because delivering a feature should already include the quality. You should bake the quality into all your processes based on your needs. If not, then it results in bad practices. You have some anti-patterns, you have hardening sprints, you have tech debt sprints, and the accumulation of QE backlog. Then the developers slip, the window for testing shrinks, and you know the drill. You go down with a downward spiral, and then you pay. The whole company pays. And I guess if you have been in this role, you met some of those pitfalls. Overtimes, missed deadlines, cutting corners. And yes, we are awesome, we can do that for one release, for two, for three. But it accumulates. It accumulates, and at some point, it will all crumble. So the answer, what we can do about it, what we can do about these symptoms of not having quality into the development lifecycle, it lies in the definition. It lies in the definition of QE mindset. The whole team needs to adopt quality. And together, we need to implement process of ongoing improvement. We need to focus on where it makes sense, where it matters. We need to pick our battles, and we need to find our constraints. How to do it? I apologize, I need to skip this one, because that would be another presentation, just this one part. But to shortly sum it up, it's a cultural shift. Everyone in the organization needs to buy in on quality. And together, you need to build a quality vision which makes sense for your team, for your product, for your service. And sometimes it might not be writing automation what you should focus on. Testing breakdown structure. It's something we need to do in order to find out what the quality vision is for the whole team. We need to ask questions because quality is not a solved problem. And it's not about creating a checklist. It's really about collaborating, finding the right quality vision. And yes, even asking questions can be misused. But if we don't do that, we will never know what is it we want. Because it's not only about common sense. Yes, quality might be a common sense, but common sense is different for everyone. So the ability to articulate what the quality vision is crucial. Some areas to ask questions about: work tracking tools and workflows. Usually, this is something you design before you start working on your product. And then sometimes it's forgotten. But it has its own risks. You can have public service, you can have public Jira project, and you can leak information there. That is part of quality. And it's important to think about the design, how we do things. Is it easy? Is it difficult? Is it efficient? Does it really cover reality? Every team evolves, and at some point, our tracking and processes the tools we are using, they lose touch with reality. Documentation, and that's a good one. It's a love and hate relationship. When you are working on something which is well documented, you love it, because whatever you need, you will find it there. But someone needed to maintain it. Imagine a situation where your company is losing money every minute your service is down. And it's down because the main subject matter expert was abducted by aliens. And, well, yes, you can get second best person or the whole rest of the team and try to dig deeper, analyze what's going on, what can we do. We don't know because there is no documentation. And at these points, you tell yourself, I wish we spent 30 minutes on documenting this stuff. It would be so valuable. Process definition. And similar to workflows, usually you create a process so that it's clear how you develop your service. Everyone knows what they are supposed to do, what is their role in the process, where they can see the backlog, where is the input, where is the output. But even if you design the best process there is, I guarantee that in a year or two, it will be obsolete. The evolution is fast, IT is moving very fast, and we need to adapt. We need to focus on what gives us the most value, even from process perspective. And it depends on what the team needs, whether it's consistency, performance, speed, robustness. We should still keep in mind that this continuous improvement in processes will improve our developers' efficiency. And this will improve the value we get from our products, and this will improve our revenue. Testing. And once again, we don't have to go deep into this. This is the part of quality assurance. Focus on what we should test, how we should test it, where we should test it, what makes sense for us. It will be different. It might be even different service by service. But you still need to ask those questions. What makes sense to do? What does not? Continuous integration. That's something we are all trying to achieve. It's modern, it's good, and if you compare it with humanity and our progress, usually we did the most progress when we were able to automate something. When something happens without us putting attention to it. Whether it's water, electricity, or productization pipelines. How can we make sure that our CI stays on top of what we are doing without asking the right questions? Are we doing things manually? Can we automate the process? Can we make it easier? And this one is a bit tricky because if you create difficult CI, then yes, you need to maintain it. You need to make sure that your environments are stable. You need to make sure that your testing environment is similar to what you have in production so that you actually don't have some false positives, etc. But it still buys you time. And you can save dozens and dozens of hours by properly automating things, making sure that whatever you do, next time it will be better. And I mentioned some other areas like security, dependencies, definitions so that people are on the same page, performance optimization, code maintainability. All of these, at some point in your product lifecycle, Well, someone needs to say, this is what we want, this is what we don't want. Someone needs to decide. Someone needs to ask these questions to formulate the quality vision for the whole team so that everyone is on board with that. And the three main takeaways from the presentation. I would like you to know that quality engineering mindset is not just about testing. It's about cultural shift, it's about having everyone on board, and it's about baking quality in the whole development lifecycle. The second takeaway is there is no one-size-fits-all solution. Every team is different, your requirements are different. What you know from the past might not apply in the future. So collaborate, communicate, implement the continuous improvements into your sprints and your quarterly plannings. And last but not least, we inherit the main purpose of our business. We try to make our company successful by trying to make our developers as efficient as possible. Thank you, everyone. That will be all for today. If you have any questions, now is the time. And I know the topic is a bit philosophical, not necessarily technical, and the questions might be hard to come by, but if you want to discuss anything, just let me know.
Going through the process again. It's so after some point get into the process not ready, so we don't need to do that again.
So the question was, if we identify our gaps, what can we do to make sure that once we close those gaps, they don't open somewhere else? And I would like to actually use something which I heard from a different presentation, and that was about agile integration. I believe it was Fernando who did the presentation. Apologies if I'm wrong, but the idea was that you cannot finish agile transformation. It's an ongoing process. You will never reach it. And the same way you can never reach quality. So what you are looking for, what you are trying to implement is really this process of ongoing improvements. Make sure that quality has place in your planning and in your capacity. Make sure that you are continuously evolving. Because the quality field, software quality field, will evolve as well. And your approaches at some point will be obsolete. So you cannot, all you need is process of ongoing improvement. Thank you for the question. So the question was whether we can design a team where development and quality are in balance, where this quality engineering mindset is in place. I would say so, but it's difficult. And since you cannot reach quality and everyone has their own specialization, first, you need buy-in of everyone. You need buy-in of the whole company. You need to shift your mindset. You need others to understand that we really need to talk about quality at every stage and properly prioritize. So it's a lot about communication, about soft skills, about building quality vision with every stakeholder which has some kind of role in the development lifecycle. Without this communication and buy-in from everyone, you will just not be successful. So if you are a quality engineer, you don't have buy-in, you either will become a roadblock, or you will get crazy. Or what you can do, and what would be my recommendation, is pick one small thing. Focus or find the constraint. For this, value stream mapping is a great tool. Find what is it that slows down your developers and work on it. Improve it. If it's good, it will be visible. If it will be visible, it will be adopted by others. And this way, slowly but surely, you will incrementally get better.
There are no further questions.
Thank you, everyone, and have a great rest of the day.